So now we are talking about lesson 3.1 rational expression. So we need to understand the definition of the rational expression here. So in this case, any expression form has A over B form, then they are all rational expression. And the other word is fraction expression as well. So before we begin, I also want to talk about rational function for a second. So rational function means any function form fx is given as fx over gx form. So in this case, this fx and gx, they are all polynomial expression. Okay, please look at page 6. Letter number 1a, please. So number 1a case, given fx equal to 3 over x minus 4. Okay. So in this rational function case, we have fractional expression here. So what is the limitation of fraction? Yes, the denominator cannot be 0. So we always find out this limitation before the beginning this problem. As you know, the denominator expression is x minus 4. So we set up x minus 4 cannot be 0 here. If you solve for x, then you say that x cannot be 4. So this is our limitation here. Now look at the problem that we want to find out certain input and output value here. So f is 0. Now f3, f1, something like that. Okay, then how to solve this problem? Yes, simply we plug this input value into this function here. Then this become 3 over 0 minus 4. So become negative 3 over 4. So this is also the same thing here. So this become 3 over 3 minus 4, which means 3 over negative 1, so become negative 3. This one, 3 over 1 minus 4, so 3 over negative 3, so become negative 1 like that. So let's cover a little bit more difficult problem like C. C shows that gt equals 2t minus 5 over t squared plus 1. The same thing. We want to find out the limitation before the beginning of this problem. So we set up t squared plus 1 cannot be 0. And now minus 1, minus 1. Then t squared cannot be negative 1. But when you look at here, after you complete all this problem using the square root, then you will get t cannot be plus and minus I, right? Because it is not the real term. Now our conclusion, this is the continuous function. So there's no limitation for this particular function. Now let's plug some certain value. So g1, then what do we do? Yes, plug 1 into all t here. Okay, so 2 times 1 minus 5 over 1 squared plus 1. So become 2 minus 5 over 1 plus 1 Therefore, negative 3 over 2. That will be the answer. What about we put fraction like g negative 1 over 2? So this case, we also plug this value into t, then 2 times negative 1 over 2 minus 5 over negative 1 over 2 square plus 1. That equal to negative 1 minus 5 over 104 plus 1. So it become negative 6 over 1 over 4 plus 1. I'm going to explain more detail how to simplify this one using complex form. But anyway, this case, we want to find our common denominator from here. So it becomes negative 6 over 1 over 4 plus 4 over 4. So negative 6 over 5 over 4. Therefore, this becomes negative 6 divided by 5 over 4 equal to negative 6 times 4 over 5. So negative 24 over 5. Okay? Yeah. Now, because we are talking about functions, so we can also talk about domain and range. Okay, but we mostly talk about domain in this case. So let's look at number 2a. The function is fx equal to 2 over x. Again, this is the rational function form, which means we have the limitation. What is it? Yes, the denominator cannot be 0, which means this x cannot be 0. Therefore, x cannot be 0. That's our limitation. Therefore, we can say domain is all real numbers but x cannot be 0. That's it. What if we indicate it using interval notation? Then, to understand a little bit better, I'm gonna using number line here. So we know that on this number line, all other value can be the answer, right? But not 0. Makes sense? So as you see, 0 is cutoff line. So from negative side to 0, but not inclusive. And then from 0 to positive side, but also 0 is not inclusive. Therefore, in this case, we need to divide two different interval value based on 0. So domain is, we can say negative infinity because it keeps on going here, comma 0, parentheses because it is not inclusive, and union because we also have the other side, and then 0 comma infinity. We can say this way. So let's look at a little bit harder question. So let us see here. So k t equal to 1 minus t over t squared minus 7t plus 12. Okay. So this case, now the denominator is quadratic form, right? The quadratic form. So you need to factor in for this expression. So t squared minus 7t plus 12. So find out two numbers. They are multiplying 12, sum negative 7. Then you will see negative 4, negative 3. Therefore, this factoring becomes t minus 4 and t minus 3, and make equal to 0. Then t equal to 4, t equal to 3. They are our limitation value, which means in this case t cannot be 4, also t cannot be 3. If they are, then it's going to be undefined value. Then what about the numerator? It doesn't matter because numerator can be 0 as well, but not the denominator. Therefore, the domain or real numbers, but x cannot be 3 and 4. Interval notation, you can make negative infinity to 3 union 3 comma 4 union also 4 comma infinity. Okay?